So in this video, I am talking about the diffusion length. That is the length of the diffusion. We know that is the diffusion process. What is the diffusion process? That is, if we include the impurity atoms or electrons or holes in a semiconductor, then the charge carrier are moved from higher concentration to lower concentration. That is higher concentration to lower concentration. Now this length is known as the diffusion length. That is how much amount of they traveling, high concentration to low concentration. So the formula of diffusion length, that is L equals to root over D into tau. That is length, so the unit is maybe centimeter or millimeter. So now we know that is what is tau. Now D is the diffusion constant, as we know earlier. Now what is the tau? Tau is the lifetime of carrier, that is carrier lifetime or average lifetime of charge carrier, or average lifetime of charge carrier. So the value of length is D into tau, root over. So now, as we know, the value of D, that is diffusion constant, equals to mu into Vt. In my previous video, you can check that is D equals to mu, that is mobility, into threshold voltage. So if we put this value onto this equation, then the length is become L equals to root over mu into Vt into tau. So this is another formula. So this is the length of the diffusion, that is diffusion length. So diffusion length depends on mobility as well as threshold voltage as well as carrier lifetime. So now what is this refer? That is the average length of diffusion depends on these three variables. Now for holes, that is L suffix P, denoted as L suffix P, that is for holes, that is positive, so P equals to root over, obviously diffusion constant for holes, that is dP, and carrier lifetime, that is tau P. That means lifetime of hole equals to, we can write mu of P, that is mobility of holes, Vt into tau P. For electrons, now for electrons, that is for negative charge, so L of N equals to, denoted as D into N, that is the diffusion constant for electrons, into tau of N, obviously electrons lifetime, that is the carrier lifetime, that is electron average lifetime of charge carrier, that is electrons lifetime. Now it is denoted as, that is Dn equals to mu n, that is the mobility of electrons, into Vt threshold voltage into tau n, that is electrons lifetime. Now after this is the formula. Maybe some numerical problems are coming from this formula. So now in recombination rate, so what is recombination? In after the diffusion, there is a recombination of charge carrier also. So they are recombination. So that's why the recombination procedure is done. So now the main point is about the recombination rate. So what is the recombination rate? During the recombination, the free electrons and hole will disappear and a covalent bond is created. So covalent bond is created. So during recombination, and electrons and holes will disappear and a covalent bond will created. Now recombination rate, the formula of recombination rate equals to majority carrier concentration divided by minority carrier lifetime. lifetime. So if this is p-type semiconductor, then what is the majority carrier? That is hole, and minority carrier electron. It is for n-type semiconductor, then what is the majority carrier? Electron, and minority carrier is holes. So now, since recombination rate, so what is the point? That is recombination rate we denote R, let R. So rate is equal for hole and electrons. For p-type semiconductor or n-type semiconductor, or for holes and electrons are equal. So recombination rate is equal for both electron and hole. So for this equation, now for in left side, if we denote as concentration P, hole concentration divided by minority carrier. For n-type semiconductor, the minority carrier is obviously electron, so the lifetime is tau n, denoted as electrons lifetime, equals to, obviously for n-type semiconductor, the concentration is denoted as n, majority carrier, and minority carrier is hole, so that was lifetime of hole. So now, so for n-type semiconductor, for n-type semiconductor, so tau, so what is the value of tau n? Tau n is become P by n multiply P into tau P, so tau P. So as we know, that is for mass action law, what is mass action law? So P into n equals to Ni square. So obviously, so now P is Ni square by n. So what it become? The equation is become carrier lifetime of electron equals to Ni square by n into n multiply, that is n. So Ni by n, the whole square, into tau P. This is the most important equations, that is the relation between tau n, that is the electron lifetime by whole lifetime, equals to Ni square by n, the whole square. So this is about the recombination rate. By this we can get the value of the lifetime also, and value of, we can finding the recombination rate for hole, that is P by minority carrier lifetime, that is tau n, and for n-type semiconductor is n by tau P. So if both are equal, that is for n-type or p-type, or for electrons and hole, both are equal, so that's why we get this equation. Now for n-type semiconductor, that is we only get for tau n equals to cross multiply, then P by n into tau P. So by this, from mass action law, P into n equals to n square. So P is value n square by n. So after putting the value of P into this equation, we get the lifetime of electrons equals to Ni square by n, the whole square, into tau P. So in the next, that is we discuss about the Hall effect.